Sandeep. He is assistant professor in the ECE department at Bharat Institute of Technology, Meerut. I welcome him for this course, and he'll be handling the session on hardware validation using Arduino. So you have seen the basics of Arduino, but now he will tell with the some other modules which can be connected, Wi-Fi modules or Zigbee modules, which can be connected with Mega also, so the higher version, so that you can use this in your real-time research. Okay, I hand over the session to Sandeep. Thank you, Sandeep.
Thank you, ma'am. I should come to on this mic.
No, नहीं there itself.
Okay.
इस आपकी mic है, थोड़ा loudly बोलो.
Okay, thank you. Okay, good morning everyone. I am Sandeep Gupta. As I am told, I am going to introduce about the Arduino Mega board. This is a Mega board which is used for research purpose. Whenever we do research, we try to make our system so that in the implementation part, so that we can show our results in real-time process. For making this, we are going to do some experiments on Arduino Mega board with Zigbee devices, with wireless camera, and also with the simulating purpose. I start from the session. In the present session, we will introduce you three modules. I basically divide this into three modules. The module number first, we will introduce the Arduino communication with the Zigbee and with the MATLAB also. In the module number two, we will see that how we do the MATLAB interfacing with the IP webcam to your Arduino board. That means whenever we do the research in the image processing or robotics vision, we try to make an image, so that we try to capture an image and we extract some information from that. We can extract the colors, we can extract the pattern, we can extract any type of pattern, so that we can do some analysis or we can do some type of research work. So for that purpose, we need a wireless camera, or we can also connect your laptop camera or simple webcam. So for this purpose, we have designed this module. In the module number three, whenever we design some logics on the simulating, so that we can implement our logic, so that like your MPPT algorithms, like your some DSP algorithms, like any type of robotic control theorem, PID controllers. So we need simulating diagrams, simulating environment. Generally, researchers are basically works in two types of MATLAB platform. Sometimes we work on coding and sometimes we work on simulating, and sometimes we work on both platform, MATLAB and simulating also. So in this module number three, we will see that how we can use our simulating diagram to connect our Arduino board, so that we can do some real-time processing. Now I will start from module number one. In module number one, we will talk about Arduino and Zigbee devices. For that purpose, first of all, we will see that how we understand our Arduino board. In the last lectures, you may have some knowledge about the Arduino Uno board, but in present, we will see that how Arduino Mega board is much better than your Uno board. In the present slide, you are seeing that how the Arduino board is just advanced version of your Uno board. In the present, we see that in the red rectangle box, we have a Uno board. Like your Uno board, we have 13 digital input pins, one RX, 0 TX, 1, and we have some analog inputs, and we have some power options like 2 ground, one 3.3 volt, and one 5 volt. At the same time, in Arduino Mega board, we have some extra features. In the yellow block, you are watching that there is some extra pins which are included in Arduino Mega board, and in the your left hand and right hand side, you can see that there is a difference between Mega and Uno board. In the Mega, we have 54 digital input pins, whereas in Uno board, we have only 14 digital pins. Whenever we require a number of pins which are basically used in multi-level inverters or some type of application where a large number of pins are required, so we use this simple Mega board. It is just a just advanced version of Uno, and near about twice cost of your Uno board. We can see there are 14 digital in sorry, we can have 14 PWM pulses. Whenever we design some power electronic device, basically we work on PWM concept. So for designing PWM, we need some PWM outputs. So we have 14 inbuilt PWM Not working. Okay, sorry for interruption. Second slide. So again, a second diagram of Arduino Mega board, which have shown that we have digital input out pins with the help of green color, and with the help of yellow color, we have shown that they are analog pins. The red color shows that there is a ground pin and is your plus 5 volt and 3.3 volt. We have a user interface to connect your system with this Arduino Mega board, and we have some RX and TX LEDs which blink whenever we download our program or we communicate with serial communication. There is an inbuilt test LED which is called test LED. It is again connected on the pin number 13 as in case your Uno board. We have an external power supply over here. We can do your Arduino board in the real-time operation. So we can connect our 12 volt adapter with this pins. Now we will understand that how we connect our Arduino board with the help of Arduino IDE tool. In the Arduino IDE tool, we have a simple sketch. The main window of this is like that. We have a file and we have added.
All the nodal centers, just wait for a minute. We are changing our system, so just bear with us for a 5 minutes. आई थिंक और दोबारा से अब ना स्टार्ट कर दो स्टार्टिंग से। विजिबल है ना यहाँ से?
नहीं अब दोबारा से जितना आता है उतना दोबारा से करेंगे।
हाँ जी।
Okay, sorry for interruption. We have just a few problems. We were explaining about you about the Arduino IDE, and we have done this one. I was talking about the examples in your Arduino development board. We have a lots of examples in the Arduino examples folder. Just like you want to connect your digital input outputs, if you want to connect your analog inputs, you want to do some serial communication, and even you have some sensors like your accelerometer, your current sensor, your servo motor, stepper motor, DC motor, everything is just in this example folder. So whenever we start our IDE and we want to connect your Arduino board, and I have an Arduino board like your Arduino Mega board. This one is your Arduino Mega board, and if we want to connect this with our system, then we have to do some steps like we will collect on tools and we will click on board. There are lots of board available which are inbuilt in this Arduino IDE. Let's for example, we have Arduino Uno and Arduino Mega, Arduino Leopard, Arduino Nano. Whatever board you want to connect, you have just to click on that and you will be just connected. In the present case, if we connect on Arduino Mega, it will just behave like your Arduino Mega programming. After that, in the second step, we will go for tools and we will connect your serial port. To check the serial port, what is the serial port, where it is connected, we can use the device manager, and there you will see in your port symbol that there is some connected device. There will be written like Arduino Mega is connected, and it will be some COM port assigned. Whenever you connect your Arduino board to your system, it will assign a port to your Arduino board, and every time it will connect your system with your some COM port. So please remind, you have to connect with your COM port. So select the serial port in your COM port. After that, you will see there is a simple sketch folder where we write our program. We write our program in your void loop and we put our configuration in the void setup. In the void setup, basically we define that how we are going to use our analog pins or digital pins. Whatever we are, if we are going to use serial, then we have to put here serial.begin command. In the case of your making your input or output pins, we have to define with the help of pin mode. If we define pin mode as 13 as digital high, and it will behave like your high input. And if we put pin mode 13 as low, it will behave like your low input. So in the second loop, in the void loop, we put our program which is run in the continuous mode, because whenever we do embedded programming, we write our program in the while loop. It will again and again repeat itself. So we write our code in the void loop segment. Next, after that, whenever we have connected our Arduino board, we will just put our Blink program in that board, and it will just behave like your connection is established. In the second part, we are going to see that how Zigbee modules, what are the Zigbee modules, and how we will use the Zigbee modules. There are different types of Zigbee modules available in market, and we have some Zigbee modules in the present slide. As you are seeing that we have a frequency, different frequency in the second column. We have a different frequencies like 2.4 gigahertz, 900 megahertz. So whatever you will purchase a Zigbee board, you will get the different versions. In the present, I have a Zigbee S1 module, and you see it is a Zigbee module, this one, and we can disconnect also like this. And we have an adapter board. For communicating the Zigbee device, we have to use some adapter board so that we can do some programming tasks. After that, we will see that what is a Zigbee module. Basically, we works on the transmission and receiving type of data transmission or analog commands or digital commands. So this board is basically used for sending your digital commands as well as your analog commands. In the range of this Zigbee module, we can see there is a maximum range of near about 3 kilometers, and we can do different types of Zigbee modules to do different type of range. We can get 100 meter, 200 meter, 300 meter, up to 3 kilometers. Whenever we require to control our quadcopter, or we can say our small airplane for surveillance purpose, we can do this type of module. And for that purpose, this is very useful and easy to use. In the second slide, we will set up a Zigbee communication between the two Arduino device, because we are going to make some embedded system, or we can say some dedicated applications. So for that purpose, we will show you that how we can connect our simple port to your Arduino board, and the port will be connected to your A0 pin, that is your analog pin, and the transmission and receiver lines are connected to your Zigbee modules. Here I have shown you that in this figure, we have a 3.3 volt first pin. We have to connect your 3.3 volt pin to your Arduino Mega board. There is your 3.3 supply. So please be connected. After that, we have a two pins, that is your TX and RX. These are the pin responsible for transmission and receiving of your data. In this Zigbee module, we can connect your system with the transmitter as a receiver also. In the Zigbee module, basically a trans-receiver type of communication device. You can use this as a transmitter, you can use this as well as a receiver also. In the present setup, we have make a connection with the port. The port basically behaves like your analog input, and we can connect any type of sensor also over here. So I have used a 10 kilo ohm of port, which is connected to the A0 pin. You can see over here, this one. And the Zigbee modules, we have to connect the only 4 connections. First one is your 3.3 volt supply. Last one is your ground pin, and 2 pins are RS and TS. Please make sure that the Zigbee pin number 2 is your transmission pin. So it should be connected to your receiver pin of your Arduino Mega board. And the transmitter of Mega board will be connected to the receiver of Zigbee modules. You can see over here. And the receiving end, we have the same type of connection. We will do the repeat connection. We will do the transmission connection, which is shown by blue line, to your RX pin of Arduino Mega board. The green line shows that the RX pin of Zigbee board will be connected to the TX pin of Arduino Mega board. This device can be used as a transmitter or as well as a receiver. In the next video, we will show that how it will work. Before that, I would like to explain you the program which is behind this everything. We have a simple Arduino code, which is a transmitter code. We can see that there is a serial.begin command, which set up your serial communication with your system and Arduino board. Now, we have used a simple command, that is your analog read pin A0. At the pin A0, it will get the analog input from a potentiometer, and it will save that value into the value integer. After that, we will use the map command. What do you mean by the map command? This command is basically used for mapping the 10 bit to the 8 bit, because I have already told you that it is a 10 bit of ADC. So we get the analog input in times of 10 bits. So it is generally 1024. So we have to convert it into the 8 bit, because we are just sending the value in the ASCII format. So we have to convert it into the 8 bit value. So I have taken a second variable, that is your M value, modified value, and it will map your 1024 to 255. Now, for transmission, we have to send some start symbol and your end symbol, because in the transmission protocol, we have a lots of words which are sent with the this Zigbee device. So we have to make our input with some start and end symbol. For that purpose, I have used these two symbols. Between this, the value will be transmitted, and we have put some delay so that we can see it on your serial monitor, which is inbuilt in your Arduino Mega board. At the receiver side, we have to write some program so that we can receive the data by the this Zigbee device. We have to use some variables like started, ended. I will explain in the next that how we will use it. Incoming byte, message. In the void setup, again, we have put serial.begin, and we have taken an LED like for output pin. In the code of receiver, how we will use it? You will use your serial.available command. For that, if any data is coming, then this loop will behave, and this loop will work. You will get the incoming byte value, which is coming from serial.read. In the serial.read command, the value will be read by this incoming byte.
the value will be stored. For the receiving, we can see the program that in the incoming byte, if it is this symbol, this is your start symbol which I have put in your transmission program. So if the incoming bit is this, then it means that the data is coming which is your valuable for you. Now we will put the started as true. That means we are going to get your value. We will put your index at 0, the first array in the message 0, and it will put your 0. After that, if else, it will start putting your values in your index folder. After that, if there is a incoming byte, this symbol, then it means that the data has been ended. So between these two values, we can store our data. This loop will break whenever we get this symbol, the AND symbol. This is the main logic. We get the incoming byte in our message array, message 0, 1, and 2. We will get 3 values, as we want to send the values between 0 to 255. So we need 3 characters. So we will use message 0, 1, and 2. Before, whenever the index is less than 4, the program will terminate. Okay, so we will receive 3 values for 3 inputs, like 3 values, like 255 maximum value. If there is 1, 1, that means the program has been taken start and end value, and between 3 values the program should end. And if it is 1, 1, both are trues, then we will convert our A to I message. That means we will convert our value array to integer value. The message, whatever is in this array, we will convert to array to integer. We will get the value in value. After that, we can write the same value to your LED pin. The LED pin, that means you will get that if you send a 255, the intensity of LED will be full high. And if you receive the 127, that it means your intensity of light will be just half. So we can check that we are getting the same value or not by the potentiometer. In the serial print command, the value will be seen in your serial monitor. This is only for debugging, so that we can we can check that the value is receiving correctly or not. After that, we will put index 0, message 0, and started and ended. This is all about your receiver program. Now I will show a video which will tell you that how we do this one. In the example, excuse me ma'am, second, इसमें वीडियोस कॉपी नहीं हुई है, इसको कॉपी करना पड़ेगा।
पेन ड्राइव में डाल के कर लीजिए ना।
हाँ, इसको स्टॉप कर सकते हैं,
इसको कॉपी कर दिए सर, इसमें
अभी कॉपी करना पड़ेगा, अभी ऑनलाइन है ना, तो
एक सेकंड। ये सारा एक आपका ही डेटा है?
नहीं, ये अभी इसमें से कॉपी करना पड़ेगा सिस्टम में से।
ये पेन ड्राइव में है ना?
हाँ,
वही नेम रख लीजिए, पेन ड्राइव पे है।
नहीं, I want to the video which is in my system, I want to
सर पेन ड्राइव में आ जाएगी ना, ये डाटा सिस्टम नहीं देगा, जाते वक्त डिलीट कर देना।
Okay, it will take some time.
आपका अर्जेंट कौन कौन से है जो आपको चाहिए इसमें से?
इसमें से फिलहाल तो नहीं, तो सिस्टम से हमें यहाँ से कॉपी करना है, पेन ड्राइव से।
तो जो पेन ड्राइव से इस सिस्टम में चलाना है वो कौन से है?
वो तो है, वो तो सिर्फ एक ही है फोल्डर जो हमने पीपीटी खोली हुई है।
एक ही करेंगे।
हाँ,
बस पीपीटी है ना?
हाँ, बस पीपीटी है ये। इसमें आप उनको मैसेज पास कर दीजिए कि 2 or 3 minutes we need.
सर उनको चलेगी आवाज.
Okay. कर सकते हैं सर स्टार्ट में?
हाँ जी।
अच्छा ऑनलाइन ही है.
हाँ जी।
Okay, sorry for again. And in this video, we can see that how we transmit our data. You can see we are going to select our board and port, and the program which is written is your transmitter side program. And here we are going to see that we are getting some value which is input from potentiometer, like we have getting 3, 4, 5, and in the setup we can see there is a Zigbee modules and there is a potentiometer, and we change the potentiometer value like this, and there is your Arduino Mega board. You can see the value has been changed like this. So we can get the different values on the serial monitor in the debugging process. Now we will see that how we transmit this value to the other Zigbee device. In the receiver side, we have the same configuration which I have shown you in the earlier PPT, and we are getting the value on the same serial monitor in the second laptop. We can see there is written as a receiver program, receiver board, receiver code, and we have selected the same process board and the port. In the serial monitor window, we can see the value is coming from your transmitter side. We can see it is a value like 24, 26, which is coming from your Zigbee device. So we can do this type of work. We can set up our work for the purpose of communication. Generally, if we want to send our signal, analog signal from device from the remote area, we can receive it your Arduino board like your simple experiment. So for hardware validation, what we do, we try to set up a system so that we can do our research. In the first program, you have seen that the Arduino board can be used for real-time application. Now, in the second PPT, in the second video, I will show you that if you want to communicate 3 potentiometer, then you can do the same thing with the same program, and you will use a single Zigbee to communicate between the 3 potentiometer values to your Arduino board. Basically, this is used whenever, suppose we want to set up a system for MPPT control algorithm or some PV research work. So we need some control, we need some current, or we need some voltage, which we have to send to our destination device, destination place, because the solar panels basically are connected on roof and we cannot make our setup over there. So we have to do some communication device so that we can get some analog value of current or voltage, so that we can do some experiment, we can do some research, or we can log our data. For data logging purpose, this device also can be used. In that experiment, what I have done the 3 inputs from the potentiometer, like your sensor, any type of sensor you can use. In this type of programming, what will you use? You will send 2 characters like start and end for M0 value, and you will put your second character for second value. After that, we can see there is 3 value basically. First one, this value M0, second one is this, which is between the bracket value, and this is the third value. So we can put any type of symbol over here so that we can differentiate our 3 values. In this, we have seen that. Now on the side of receiver, what we will do, we will again do the same algorithm so that we can extract the value, extract the information. Now what we will get? We will get 3 values with 3 start and end symbols. So if the data will start from start symbol, what you will get your start value. And if this value is coming, that means you will assign your index 1. That means index 1 and message 1 for second value, and index 2 and message 2 is for third value. So we are using this algorithm for getting 3 values. First value will be start from this, second value will be this, and 3 value will be between this. At the end, the end bit will be your last bit of your third analog value. So we will put this bracket over here. So if this receives, that means you have got all 3 values. In the second type of else, you will get your first value in your message array. In message 1, you will get your second value, and in message 2, you will get your third value. Again, we will use the array to integer value and integer command so that we can convert our message to your particular integer value. Like this. It is very simple. It is just a modification of second program, first program. Here we will use serial print value. So to get the value, whatever we are getting from your potentiometer 1. So we will print like this. For value number 1, we write the 3 commands like this. This is command only for getting some space. And this is your third value. So by doing this, we can get the 3 values. Now we will see that how we do in practical purpose. For that, I have made a video so that you can better understand this one. This is our transmitter program, which have the 3 arrays and 3 values. Now, let me stop it. Now you can see there is 3 value which is transmitting from this. This is your first symbol value, and this is your second value, and this is your third value between the 2 symbols. This is your first, this is your second, and this will be your third. And the receiving end, we will again do the same process. Now we see that how we do it. You can see this is the values which is coming from your potentiometer 1, 2, and 3. There is a Arduino module. Here we have a Zigbee device, and we have connected 3 potentiometers to see and to show that how we can put 3 sensor values. You can see that there is a LED is blinking, which is showing that the value is transmitting through this Zigbee device. At the second end, we have a receiver like Arduino and your Zigbee device. In the second, we have a program which I have explained you right now, and this program is burning on your Arduino second board. So whenever we open our serial monitor, we will see that we will get 3 values. Like start is for start value. Value is my first value. It is your 49. Second one is 42, and third one is your 31. This values you are getting. So we can see that how we are getting the 3 different values of potentiometer 1, 2, and 3. So by this type of experiment, you can get number of values, because I have already told you that Arduino Mega board has 16 output pins. So we can get different 16 output input analog values to your second receiving end. So this is really very useful in your research whenever we want to get some values from your okay. Now we will see that how we can do this in your MATLAB programming. This is the next experiment number 3, in which we will see that how we can get your values in your MATLAB environment. Because we do research on MATLAB, so we can easily get your values, and we can store that values. We can do some analysis for that data. So for that purpose, I have made the third experiment. Before starting off the third experiment, we will see that how we communicate with your serial device to your MATLAB environment. In that purpose, you have to create a serial object like this command. This is your serial communication commands which are available in your MATLAB. So the first command is your serial command. It will create an object like S. You have to assign a COM port which is done in your Arduino. So same COM port should be over there. After that, you will use board, a name, a symbol, and 9600. The board rate should be same for between the transmitting and receiving device. I mean to say, transmitting now is your Arduino board and receiving is your MATLAB. So we will use this command for making an object. Now fopen, this command is open your Arduino board to your MATLAB to start communicate. After that, we have a command that is your fprint. If we want to print, if we want to send value to your Arduino board, we use your fprint command. That means S comma value. Value can be anything. Whatever you will write over here, it will transmit to your S. That means you can communicate your Arduino with your MATLAB. In the next command, we have your value is equal to scanf. If you want to get a value from your Arduino, you will use your scanf command. If you want to close your serial communication, then you will use fclose. After that, delete S. This is the basic command which can be used for your communication with your Arduino device. Basically, what we are going to use, we are going to do the communication between Arduino and your MATLAB. And the Zigbee is already communicating with your Arduino. So indirectly, we are communicating with your Zigbee device. For the transmitting side, we have to, first of all, we have to set up for transmission of your Zigbee device. It is basically a same program which have written in your previous transmitter for MATLAB. This program was for transmitting your value from your Arduino to your Arduino board. This one. The difference is between that, we will read the analog read A0s. We are getting the potentiometer value in your value. But in your MATLAB, what we will use serial read. If we want to read our value, read some serial value from your Arduino board, we will use the serial read. Or if we want to write some value, we will use the serial write. In the present experiment, I am going to get the potentiometer values to your MATLAB window. That means it is a setup like that. You are going to get some voltage or current from PV panels which are installed on your roof, and you will get these values to your MATLAB window. Okay. In the receiving side, that means in your MATLAB environment, you will write a simple code like S is equal to serial COM37 board 9600. This program will be written in your MATLAB environment and you will run it. It's a simple program. We have used serial command to make a serial object. We have used fopen for opening this, and we have done I is equal to for this time frame. We are going to get some values. Now I have used fscanf command so that we can input the values from your Arduino board, and it will be saved in your A variable. Now it will see that port value received. Whenever you will receive a value, the s print, that means it is the only print command which is used to print the value to your MATLAB window. So s print basically is for printing, and f print basically is for objects which we create, and it will create and will put your A value on your MATLAB screen. After that, we will end and we will close this. Now I will play a video which will be explaining about the transmission between your MATLAB and your Arduino board. In the receiving side, we have the same parameter, we have the same transmission code, and we are seeing that we are sending the value which is coming like your 888. It is a potentiometer value which is going to send by your Arduino board. This is the simple setup. In the second, we have a transmitter and receiver. Okay. Now this value is transmitting to your Arduino board, and this is your potentiometer. Now you will see there is a MATLAB window. In the MATLAB window, we can see the code which I have written on this. When I run this program, what we get, I get the potentiometer value received, which I have done with the help of sprint f command, and you will get the same value. It is, your value is coming like 8. So by this experiment, you can receive your analog value to your MATLAB window now. Whenever we do some type of work, it is very useful for us, so we can implement our projects. So it is one part of your Arduino and Zigbee communication. Here our first module is completed. Now we move on the second module, which is basically designed for image processing, or we can say your robotic vision applications. In this type of experiment, what we do, we are going to use your IP webcam, your Android phone, for making your Android phone as your wireless camera. It's very simple, and without investing some amount for purchasing your IP webcam, we can use your Android phone for like your simple wireless camera. For that purpose, we have to step number first, we have to download the IP webcam app from your Android phone. We have to turn on your mobile hotspot. After that, open your IP webcam app and select the start server. After that, what will you do? You will connect your PC with Wi-Fi enabled capability, or your laptop. Same hotspot will be connected. After that, what we will use, we will check that how we are getting our input from your wireless webcam. For that purpose, please type the 192. This IP will be same for your every type of IP webcam systems, and click on the flash and video. I will show a video that how we do this. Here you are seeing that this is your Android phone and this is your object. We are going to get this value on your MATLAB screen, or we can say before that we can just type your IP over there, and we are going to receive this value from your wireless camera. So I have selected this one. This window will appear, and on this window we have a video render and we have an audio player. We can also get some audio, but for present purpose we are working on the images. So we will click on the flash, and you will see that how we get the real-time video. In this video, you are seeing that we are getting the real-time video which is coming from your wireless camera and connected with the your hotspot. You can see it is a running, and specialty of this one is that you no need to do any type of internet connection. We are just going to use your hotspot connection over there. Okay, fine. So this is your experiment which we can do. Next, we will say the simple algorithms which works on the image processing. In the first example, we see that how we get an image from your wireless webcam to your system. In that purpose, you have to use simple command, like you will use a command that URL. Please type this command over in your MATLAB framework and use a IM read, that is image read. A URL value which is going to get, it will get like a shoot.jpg. It will get a image, and it will be, the value will be stored in your RI. Then you will convert this RI to your image. Okay, I will play a video like how you will get it, and you can see in MATLAB environment how we get this. Here we have a 3-line code, and we can get the value which is coming from wireless camera. And you can see whenever you run this code, you will get a figure 1 window, and you will see the picture which is sent by the URL Wi-Fi camera. It is on your web MATLAB window. In the second experiment, what we see, we will use the video for our purpose. If we want to make a runtime of video, we can use these simple commands. Like the 3 commands are previous commands, and we are going to make the pictures which are getting to your video. For that purpose, you will use these 3 commands. It will be infinite loop, and you will whatever you are getting in your RI, you will just put the set fh, c data, RI and draw now. And by using this, you can get the video from your wireless camera. Okay, I will play a video which will show you that how we use it. In this video, you are going to see that how this is the line code which I have shown you right now. And you can see this is your video which is coming from your wireless webcam. You can see it is a running, it is not a still image. I'm just moving it, and it is just your runtime video. So this experiment is used for getting a video from your wireless camera. It's a simple experiment. Now we come to some more stuff, like how we check our image. Suppose we have a red object in your image, so how we extract that red object? Because we do image processing, we take some red object, or we can also do some pattern recognition or character recognition. That is simple algorithm of image processing. You can go through about image processing toolbox, whatever you are going to use. But right now I am telling you that how we can use this with the help of your webcam. So I have written a simple code for getting your red image. The one thing which is you need to know if you are beginner, then it's a simple command. You have to write this algorithm, and please be concentrated on this black portion. If in the IM subtract command there is a 1, if it is a 1, you will get your red component. You will extract the you will detect the red. If you put it over 2, then you will get the green object. If you put 3, you will get the blue object. Basically, there are 3 prime colors RGB. So in any image, we can get red, green, or blue by the simple putting 1, 2, 3. There is some other techniques which you can also get the yellow, brown, or black, or white, whatever color you want to get. There is some basic other algorithm, but for basic, we will use our 1 for getting a red object. After that, you have to put your threshold value over here so that you can easily extract your image. For experiment purpose, I have written 0.18 for red color, and 0.05 for green, and 0.15 for blue. Please put it and try it yourself. It is very easy. After that, what I am going to do, if you are getting a red color, if you have easily detect the red color, what we will do, we will use sprint command so to print the value on your MATLAB screen. After that, a beep sound will be there, and you will see that a beep is coming if there is a red object in your image. Else, it will show that not beeping. That means red object is not in your video. Okay. Now I will play a video in which you can see that how we extract the red object. You can see there is no object in the video framework. We are going to run the same code, and after that you can see if we run this code, what we will see, this one. There is no red object in the object. What you will get? You will get not beeping. That means there is no red object basically. And if there is any red object, what it will do? It will just beep sound will be there. Now you can listen, and this is beeping. That means you have detect a red color in your video framework. If you put aside your red color, you will see there is no beep sound. Okay. So this is your basic example in which we can do experiments for red, for green, for white. You can again see if you put a red object, it will behave like you're beeping your object. Fine. So with the help of this simple experiment, we can start our research on image processing. Now we will go that how we can use this algorithm for making some real-time applications. For that purpose, we have to connect our Arduino board over this. Suppose I have a simple experiment that we want to check a red object in the image, and we want to do some application like a robotic arm will move if it get a red color. It will pick the red. It can pick a red color ball, blue color ball, or yellow color ball. For that purpose, we have to connect our Arduino board over there. In this type of experiment, we are going to mix the image processing with your real-time system. Basically, it is for implementation purpose. Whenever we implement our algorithms on mobile robotics, for autonomous robotics, or we can say a robotic arm which is far placed to you, you can do the Zigbee communication with Arduino and MATLAB in the same which I have told you earlier. And right now, if you're getting an image from that, now you can extract the image, red color over there or not, or any type of color or any type of character is over there. Your Arduino will work and your arm will move like this. So we are just connecting everything to your implementation part. For that purpose, I have a simple example for that. You can see in this area, everything is just like your previous, and in this area what we see, we just put your fprint command over there. If there is a red color in your image, what you will put? You will put fprintf. That means you are sending a value to your Arduino board. That is 100 value. 100 is for red object. If it is not a red object, you will send some other value. It will be 101. Sorry, it is some mistake on over here. It should be 101. So I will show you by practical example, and this window will show you there is no red object, and in the Arduino board there is no LED is blinking. Okay, LED is 30 number off. Now we have this code, and we can see this code is written. I can show you that the s.serial is used for making the serial object. fopen is used for open your Arduino board. URL for making your IP webcam to enabling in your MATLAB environment. The same 3 commands, and we are getting some video. It is just previous. Now after that, we do the algorithm for getting some red component. We use the same algorithm, and in the next if else statement, we have get that bw1 is your parameter which is getting some red object, counting red objects in your image. So if bw1 is more than 1, that means if there are more than 1 of red objects in your image, what it will do, it will print a beeping command, and it will beep. The the MATLAB will beep a sound. In the fprint command, we will send 100, and in the if red object is not there, it will send your 101. That means you will see that how we can send this value to your Arduino board. Now we will do some experiment like this. If we run this program, what you will see, now the program is running, it is busy, and now there is no red object in your image. So what we are getting not beeping, and LED is just off. This LED is for transmitting, it is not for bugging purpose, it is just for transmitting. No red object over there. If I put a red object in an image, what you will get, You will get this value from your Arduino webcam, and it will transmit to your system, your MATLAB window. Now beep sound is coming. That means your MATLAB is getting it, and now you can see the LED is turned on. Now this simple example show you that how you can send your command according to your image processing. If you recognize a character, you can send that value to your Arduino board. You can do different type of application. You can perform on different applications. Again, we can see it is beeping. For checking it correctly, we will remove this object from the image, and we will see that it is beep or not. At the time I remove this object, you will see there is no beep sound and LED is off. Okay, that means you are going to use this type of experiment or this type of application for making some image processing in real time. Do some hardware things which can be used for implementation part. So this was the Arduino with MATLAB, and we are going to move some MATLAB with your Simulink so that we can understand that how we can do the Arduino with your Simulink environment. Okay. Give me 1 minute. I am just going to initialize the Simulink block in your Arduino IDE. Sir, can we show the screen? Screen.
कोई स्टूडियो कहाँ रहा है इसमें
Okay. Okay. It is visible now. Okay. Now you can see there is a Arduino IO package which is available on your MATLAB MathWorks website. You can just download it and you can do some experiment with your Arduino board. For that purpose, you will get a Arduino IO package folder. What will you? You will use your Simulink block, and there will be a library which is used for Arduino. This one is the library Arduino IE.mdl. When you will click on this library, you will see there is a lots of blocks which are available on this library. This library can be used for real-time programming of your Arduino board. There is some predefined blocks which are available in this. If I open the blink example, you will see that we can blink our Arduino board to your we can blink the program with the help blink the Arduino LED with your MATLAB window. Fine. You can see there is a two setup blocks. In the first setup, we have a Arduino and it is COM37. You have to change your COM port as whatever your COM is selected for your Arduino board, and it is for speed 1. If you run this program, what you will get? You will get a 1010 or blinking LED in your pin number 13. Okay, so this is the simple IO blocks. We have a digital, we have some examples over there. We have a servo motor example like this. Okay, now I will show you a video which will show you the physical implementation of this type of blocks or this type of programming. In the first video, it's working. So you can see this video. For that purpose, you have to first download IDE INO in your Arduino Mega board for communicating the purpose, for making the library compatible, Simulink compatible with your Arduino board. Once you have done is, that is your IDE IOS folder. It will be in your Simulink block. So if you do this one and you do the programming, and if you open the library, there is some library over there, and we are going to see the simple LED blinking program. So this program is there. You can see we have changed our COM port. After that, what you will see, the LED is blinking. Now we are running your Arduino board with your Simulink block. So we can do the experiment, we can do some implementation on your Simulink. Whatever you do on your Simulink environment, you can directly send your command to your Arduino board. This first example show like this. Okay, in the second video, I will show you that how we can control our robot with your Simulink diagram. So this is a simple robotic arm which have a 2 degree of freedom. It can grip or it can move up and down. So I'm going to use a second example of your servo program. Here I will slide with the help of this slider gain. I will change the value and this servo arm will rotate. Okay, I am just putting the sliding down and you can see the servo motor is working. So for that purpose, for Arduino, for a robotic application, you can use it. You can control easily with the help of this simple slider gain. Now in the second, if you open the second slider gain, I can control the gripper command. Now this a robotic arm just gripping your object, and now again I have do the second servo motor that is just upping, which are just pulling up this object. So I am just controlling this everything with the help of your Simulink. Okay, so now you can see that this type of application can be made with the help of this Simulink diagram. We in the power electronics, what we do some on your real-time application. So whatever algorithm which you are going to implement it on Simulink, you can put over this diagram, or we can design on your this system, and we can do different type of things. So this is your very valuable for you. For making any type of electronics device, we use some this type of experiments. So this is your robotic experiment which is going to use in your Simulink environment. And for that purpose, if you want to do some inverter applications, for that we will do the PWM pulses or different type of pulses. We will make a diagram in this window and we will send with the help of some digital input output pins or PWM pins. So we can use optocoupler, MOSFET driver ICs, whatever you do on your Simulink platform, you can easily connect. Just do these two blocks on this Arduino platform and use your Arduino digital pins for real-time applications. Okay, fine. So this is very useful for your engineering research, and for implementation purpose, you can easily do it. And if you want to make a standalone application with the help of the Simulink, there is a Simulink package also available on the internet, on the MATLAB website. So over from that, you can just download it and you can burn the program with the help of your Simulink environment. So it will behave like your embedded system or standalone system. Or okay, now it's all about some module which I have explained, all three modules, and you can send me any email if you want to have any doubt or regarding this. I can provide you the package. I can provide you all information. I can share the slides which I have shown you, the programs, the video, whatever you want to use in your research. So please write down this mail ID and you can mail me anytime, and I will be just responding you for the purpose. Okay, and this is all about for present course. And thank you very much. If you have any question, then it is open for now.
Do you have any questions from the centers? So now we will break for tea, okay? And we will reassemble after 10 minutes. I think at 11:35. 11:35, because we will sharp at 12:30 we will end the next session also. Our valediction is at 12:30. So for all the other centers also, the valediction is at 12:30. So all of you get assembled for the next session at 11:40. We will start at 11:40 and we will end the session at 12:30 and we will start the valediction at 12:30. So I request all of you to reassemble at 11:40.
Thank you. Thank you. Hello.
Yes.
Yes. Yes. Yes. Sorry, sir. Yes. Yes. You are. Which one, sir? You are going to connect a robotic arm. Robotic arm can be. Hello. Are you getting me? Basically, robotic arm basically works on servo motors, or we can say stepper motors, right? Or we can use some DC motors also. So for that purpose, we have a library in your Arduino library available over there. We can use a simple task with the help of your stepper motor with the servo motor and DC motor. It is already available in your library folder. You can do it. Okay, sir. Any other question from any center? Okay, thank you.
ये चीज तुम्हें तो मायने बैठा लो जो भी तुम कर रहे हो कैलकुलेशन मुझे नहीं ना आ रहा है अच्छा आ रहा है तो अपने कर रहे सभी का पैसे ले ले 2 बजे तक यही चलो ऐसा करो ना पहले से तो तुम ये देख लो माइंड में ध्यान दो तुम्हारे पास एब्सोल्यूट वैल्यू है इसलिए मैं थर्मल से कंपेयर किया हम तो बता रहे हैं कंपेयर नहीं किया इसे देखो नहीं तो हमारा वैल्यू नहीं है कन्वर्जेंस हो गया कन्वर्जन इसको किया एक्शन में किया रिजल्ट इसको किया हमने एमजी के वर्क सीधा चलो ये सीधा एमजी को एलोकेट दो मतलब है ना तो ये वाला ये पॉजिटिव पॉइंट है हमारे पास एब्सोल्यूट वैल्यू इसे अभी विश्व में तो तुम क्या कर रहा ये दिखाने के लिए हमारे पास तीन चार तो ऊंचे से जो विश्व में को सब इसमें कराया हुआ है उसके बाद हां मैं ये क्या है कितना करेंगे दो या इस वाला में चेंज है प्रॉपर्टी एग्रीमेंट है ना पहले कितने कौन से एग्रीमेंट है इसको आइडेंटिटी इशू पर कौन सा है इशू पर ऐसा होगा ना एक मिनट उसे ना है ना जो भी ऊपर जो नीचे वाला इसमें एक एमए वाला है ना और एक जो ऊपर वाला है ना ऊपर चेंज करो प्रॉपर्टी कैसे निकालना है ना वो डाल के इसमें यूज करना हमारे आप लोग है ना इसको क्या करना देखो ये प्रॉपर्टी और ये पावर करेगा हमने क्या करा है 30 परसेंट मिला इधर रूम में ले दोनों क्या ये मैडम दोनों मिला जाता है यहां पर क्या कर रहा हूं मैं अंदर वाला भाव मेरा कौन सा लगेगा अंदर वाला किसने मारा गया मारा है नहीं का क्या बात है मतलब ये एवेंट है एवेंट इसी की ताकि आपको लगता है नहीं वो कितना निकालना और पहले करना ये मेरा क्वेश्चन बहुत सबसे ज्यादा क्या लिखा है इसको ये क्यों होगा अब ये इसको चढ़ाई इसको लिख ये तीन को लिख दो e is equal to 3 तो इस पर e अलग आ जाएगा ये भी अलग आ जाएगा सब अलग आ जाएगा अब ये वैल्यू करो और ये कोई पावर नहीं करेगी बिकॉज़ यार ये चीज है कंट्रोल ले लो दूसरी बात ये तो e is सारे स्टार प्रॉपर्टी 10-15 का ऐसा नहीं रखो ये प्रॉपर्टी रेशियो निकालो और इनको पुट करनी है ठीक है पता है ना कंट्रोल है ना ठीक है पहले ये लोग भी आ गई या मैंने कहा वैल्यू निकाला वैल्यू लेकिन पर मेडिटेशन हां वैल्यू लिखो चेक कर रहे हैं ठीक से तो हाथ से करना वैल्यू करना दो सेकंड डैमेज क्या होगा क्या लेवल लेवल लोगों को पूरा मैं उसने दियो ये मैं उसने शेयर में करना है और इसे Kalau kita tahu kan, kita harus begitu. Kita tahu ini sih. Tapi sih tahu. Kita tahu. Kita tahu ini sudah ini sudah terpegang dari tadi. Awal itu kita उसमें के कौन से क्या है आप उसमें सर दिखाइए और टेस्ट क्यों नहीं है कि हो गया और तो हो गया यार वही कर रहा है कैसे कर रहा है बढ़िया भाई तो दास हो गया क्या हो गया नजर खराब है मोबाइल है गाड़ी है गैस सिलेंडर आप लोग इसी तरह एनर्जी इक्वेशन को मॉडिफाई करो। अब एनर्जी इक्वेशन वेलोसिटी की प्रॉपर्टी है, लेकिन कुछ फ्लो ऐसा होता है जिसमें कि एनर्जी इक्वेशन कपल्ड एनर्जी इक्वेशन सोल्व करो, वो वेलोसिटी के टर्म्स लग गया। जैसे कंडक्टिव या लेफ्ट हैंड साइड क्या आता प्लस क्यू यू डेल बाय डेल, ये जो है यू डेल ये उसमें भी आती है, तो वो कैसे मॉडिफाई AC लगाओ, इन्वर्टर लगाओ, अलमारियां लगाओ, नया फ्रिज लाओ, मॉड्यूलर किचन, नया पलंग, आइए सर, कौन सी वाली है? आइए सर, आइए।
So very good morning to one and all present here at the Litter Center as well as all the nodal centers. So now we are going to the last lecture. We have Mrs. Swati Singh. She's Assistant Professor in the EC Department at Meerut Institute of Technology, Meerut. So she will be delivering you and lecture on the hardware implementation using FPGA. So as I already told you on the first day, even microcontroller, FPGA, based on the application, you will be choosing which hardware. And for validation, this is a very important portion. So I just hand over the session to Swati. Before that, like say at 12:40, we will be completing this lecture and we will go into validation. Thank you. I hand over the session to Swati.
Thank you, ma'am. So good morning to all of you. Today, now I am going to discuss one important topic in research, which is FPGA. Basically, what is FPGA? FPGA, as the name suggests, Field Programmable Gate Array. Basically, it is a collection of array. It is an array of gates which we can program as per our requirement and field programmable. So it is basically FPGA is an integrated circuit. FPGA is an integrated circuit with having configurable blocks and their interconnection. For research point of view, to implement our research or hardware on FPGA is very much better than any other microprocessor and microcontroller. important and most important beauty of this FPGA is work on parallel basis, concurrent basis. Means here we flow data from input to output, and in case of microprocessor and microcontroller, when first of all we write instructions or our program in and store it in memory, then fetch these instructions one by one and execute. So it is they are work on sequential basis. But FPGA, the feature of FPGA is work on parallel basis, and the logic blocks are programmable, reconfigurable. We can edit our circuit, we can edit our program on runtime basis. So the term field programmable is programming in the field. In the field means at the time in the lab or where the device is installed, we can change our conditions and then reload our program and burn and execute our program. So FPGA is an array of logic cell, we can say array of gates, array of modules, and their interconnects, which can be reprogrammed depending upon the requirement of the user. So to build a very large circuit, a very complex circuit in digital logic, so we can implement on it in any other research like power electronics, robotics, image processing, DSP algorithm. We can also implement these things on FPGA also. So this is the structure of FPGA. Here you can see these are the logic blocks. We can program this logic block as per our code, and we can interconnect via these programmable interconnects. These are basically the matrix. They lie in matrix form, and they are the programmable input-output blocks by which we can interconnect outside the world. Now, what are the family of FPGA? There are several families available in market like Xilinx, Actel, and Altera. I'm working on Xilinx, Spartan Kind given by Xilinx. Now, what is the basic difference between these Xilinx, Actel, and Altera companies product Xilinx kits? Basically, the physical means for implementing programmability means there is a difference between implementing programmability methods, their interconnection arrangement, and the functionality of logic blocks. So they are differed by these means. Now the programmability in FPGA, as I show that Xilinx, Actel, and Altera, in these Xilinx and Altera are basically SRAM based. SRAM based means they are anti-fuse. We can burn our program, then reburn. Anti-fuse based is Actel. It is one-time programmable, given by Actel Quick Logic. So SRAM based programming is making or breaking cross-point connection, define function. We can define our function of logic block, but in anti-fuse based programming, it can only one-time programmable. Now, one question is arise why we select FPGA over general purpose hardware and DSP processor. Because first of all, one important parameter is high speed. When we work on DSP algorithms or in power converters, when we design power algorithm for power converters, inverters, so we need real-time data and complex programming. So we need a high speed. So we prefer FPGA over microprocessor and microcontroller because FPGA work on concurrent basis. Now, hardware design techniques which are possible in FPGA is both parallel and pipelining. Parallel means multiple action can be performed simultaneously, and pipelining, as we know about in microprocessor 8086 systems, pipeline is a concept in which when one program is executing, then other program is fetching or something else. Means we can perform multiple tasks in parallel form in case of FPGA. Flexible means because FPGA is a flexible device, we can add, subtract functionality as per our requirement. Next one is million instruction per second requirement for an application. When we work on real-time video image processing application, so we need fast speed and multiple instructions executed in a single time. So FPGA is very better for selecting, offer a much better cost-effective solution, because in very small amount we can choose a better opportunity when we select FPGA over DSP processors and microcontrollers available in the market. Now, what are the application of FPGA? We can design complex digital logic circuits on FPGA and implement these design digital controller for power electronic device, as I discussed that power converters, inverters. We can design algorithm on FPGA and implement on FPGA. In case of robotics, we can also use FPGA for motion control of robot, for sensing robot, and in case of robotics and image processing, we can use FPGA, DSP algorithms because in DSP algorithm they are very much large data, so we prefer FPGA for fast execution, video and image processing. So without discussing much more in detail in FPGA, I am going to how we work on FPGA. For very basic, first of all, if we want to work on any tool, we need to write a program. So this is the scenario by which flowchart by which we can burn our logic on FPGA. First of all is design entry, then behavior simulation, design synthesis, design implementation, and then burn our program on Xilinx device. I will explain these block one by one. What we do in design entry. Design entry is basically the first step of implementing a design of FPGA. Here we write our code on hardware description language. FPGA work on hardware description language. We can write our program in two type of hardware description language, Verilog and VSDL. In my case, I prefer Verilog because it is very easy to understand. So we need for burning a program on FPGA, we need a software which is Xilinx ISC, and we write a program on Xilinx ISC either in Verilog language or VSDL language. Now, second point is, after writing a code, we check its behavior. So to check the behavior, we need simulation. In behavior simulation, it is a next step. In this step, we verify whether the design entered by us is functionally correct or not. If there is some error, then it shows error. We can show the RTL view in this step. Third step is design synthesis. Design synthesis is basically used when we do implementation of our code. The synthesis process is used for optimizing the design architecture selected. It gives the net list is saved on the NGC format, NGC file format. After design synthesis report, basically what in this step, what we are doing, synthesis report is generated, which give information about how many logic blocks which are using. There are multiple logic blocks available in FPGA. So how many blocks which are used in our designing program, and what is the device utilization of design architecture synthesis. So basically, synthesis map the behavioral design to gate level design. So our behavior design, what we written in code, is converted into gate level design. So we can capture the RTL schematic of Verilog code which we are written in Xilinx ISC. Next one is to implement. Before implementation, we need to make UCF file. Now, what is this UCF file? Basically, UCF file is a user constraint file where we define that in FPGA, because it is a hardware description language. So in our program, if we take some input and output, so we have to define which pin we give input and which pin we give output. So design implementation, there are 3 steps in design implementation. First one is translate, map, and then place and route. Before translating the design, UCF file is written to assign pin configuration, as I told. Then next step is translate. First step is translate. Translate, what this step do? It merge your UCF file, as you UCF file and net list, which is generated in synthesis process, into a Xilinx design file. Now after that, the mapping process is coming. Mapping process, in mapping process, it fit the design into available resource. Available resource means our FPGA. And the last process for design implementation is placing and routing, which place the logic blocks of design into FPGA and route them so then they can occupy minimum area and meet timing requirement. So for a very large area of FPGA, a very small amount of area is covered by this mapping process, place and route process. After that, this operation produce a NCD output file. After that, the next step is generate programming file. Actually, there are multiple steps to produce a executable file, because executable, in case of FPGA, this executable file is XSVF file. So to implement our project on FPGA, we need to create this XSVF file. So these are the steps to create XSVF file. Next step is generate programming file. There is an option for generating program file on the process tab, Xilinx ISC, which convert the NCD file, this NCD output file, into a bit file. Now it produces a bit stream for Xilinx device. This bit file is used to program the FPGA, but we need XSVF file. So we will take next step, configure target device. In this step, there is an option for generating target PROM on the process tab of Xilinx ISC, which convert your bit file into XSVF file. This XSVF file is the actual file which we need to burn in your FPGA. So when your XSVF file is created, now your FPGA is ready to be used. Now, what are the steps when we writing a Verilog program on on Xilinx? We need these for Xilinx environment consist following segments. First of all is header. Header means we give any name of your project. It is called module name, list of input and output which we are used in your project. Declaration means if we give name in your module name, like suppose your module name is NOR, and you give input, if you give variable ABC. Now in declaration part, you have to define what is input and what is output. Suppose A and B we take input, so you have to define input A, input B, and if suppose our output is C, then you have to define output C. Now logic description, you can describe your via equation, state, machine, or logic function here, whatever logic you want to do on your input and output. And module, you have to give AND statement, which is in Verilog program is AND module. All your design for this lab must be specified in the above Verilog input format. Now, via slide, I am going to show how to create a new project on Xilinx environment. First of all, this is when you open the Xilinx, when you install the Xilinx software and open it, this project navigator window will open. Now click to create a new project. First of all, click on file and give any name of your project. Then this window will appear. Now these are the basic setting which are given by manufacturer. Just like here I am using Spartan 6 kit and Verilog programming preferred language. You can select VSDL if you want to work on VSDL, and then click on next. And Now this project summary will appear. Now click on finish. Now it make a project. Before going this, when you create a new file, this location option will show. You can give any location where you want to save your project, and direct you can also give the directory in which you want to save your project. Now when you click on finish, a gate window, a gate project is making. But to create a Verilog file, we need we need a .v file configuration here. So how to add source code and UCF file? Click on project, this one. Then go to new source and select Verilog module. There are so many options are available. Then if you want to work write program on Verilog, then click on Verilog module and then give the file name and click on next and click on this option, add to project. So this .v file will automatically add in your created folder, project folder. Then click on next and finish. Now here you can see that .v file is created. Similar procedure is apply for creating UCF file. UCF file where we address our input and output, means our input and output is connected to which pin of FPGA. So to create XSVF file, again we click on project, then select implement concentrate file, give the name, and then click on next and add, finish. Now here you can see that gate, suppose I am here, I'm taking a module name gate and. So gate underscore and dot v file, also gate underscore and dot UCF file is automatically available in your project folder. Now everybody know the basic logic of AND gate. AND gate means if you both here for making an AND gate and implement it on FPGA, we need two input and one output. Here I'm taking input 1 and input 2 and output gate output. So in module name here, module under gate underscore and, we give input. This is your header file. You give name input 1, input 2 and gate output. Now you have to declare which one is input and which one is output. Basically these are the variable. So we give input 1, input 2 and output gate output. Now to develop a logic, we need a assign operator. Assign operator, we give gate output equal to input 1 and input 2. Means when your both input are 1 1, output will be 1, otherwise output will be 0. And last statement is AND module. To write UCF file, we give these instructions. To write a UCF file, we need, and we write this syntax netnet in quoted form, input 1 LOC equal to T20. Now what is this T20? T20 is the basically in FPGA from how we can give input. So in this project, I'm taking two switches via which we can give input 1 and input 2 and one LED to show the output. So T20 is the address of input 1 and N16 is the address of input 2. And for output, we take LOC equal to AA6. Now AA6 is the address of LED. So this is how we create .v file and .ucf file. This is the table of FPGA pin. Basically, I'm working on Spartan 6 given by Xilinx. So in this kit, the LEDs address is given as AA6, AB6. If I want to use LED 5, then I have to give address Y8 in UCF file, and so on. So they have 10 LEDs in this FPGA kit, and dip switches from which we can give input. So there are multiple dip switches available in FPGA. So I am taking this T20 and N16, dip switch 1 and dip switch 2. Now, after writing .v file and UCF file, what we do next? We do, first of all, before in research, there are two things we are doing. First of all, simulation, and then implementation. So how we simulate our code on Verilog on Xilinx. So for select simulation option, select your .v file, and then select behavior check syntax. If all is okay, select simulate behavior model. This window will open. Now, to check the logic, we have to verify the truth table of AND gate. So for input, to give any input, if your input is input 1, then it may be a 0 or 1. To give 0 or 1, what we do? In object window, right click on input 1, then click on force constant and give force to value equal to 1 if you want to give 1. And same procedure will apply on input 2. To run the program, click on run symbol. This is the run symbol, this one. Now click on zoom to view. This is the zoom button. You can click on it to zoom your view. Change the input and see the result. This one. When you right click on it, this window will open. Now you can give your value in binary form. So write force to value 1 or 0. Then you can see. If you give input 1 and 1, your output will be 1. So here you can see. Now if we change the input 1 and give its value 0 and input 2 is 1, then your output will be 1, so that we can verify our logic via simulation. Now, how to implement the project after simulation, after checking your code is working correctly or not? Next step is implementation. How we implement our code on FPGA. For implementation, select this. There are two options: implementation and simulation. For simulation, you have to select this option, and for implementation, you have to select this option, implementation. For implementation, your project, click on select implementation and then select your .v file, and then click on synthesize. After synthesize, this green right will shown in front of your synthesize option. In synthesize option, when you click on this plus button, then you can show the RTL, view RTL schematic. So when you double click on it, you can show this RTL schematic of your project. When you double click on it, this AND gate, this diagram will show the diagram of your logic. Then after synthesize, implement design, double click on implement design, then generate program file. Third step is generate program file. After that, configure target device. This warning will appear. Ignore it. Click on OK. Then this window will show you. Now you click on boundary scan. When you click on it, then this window will open. Then right click on it on blank window and open .bit file, which is automatically generated when you synthesize and implement your project. Now, select output, this output option, and create XSVF file. Now save and right click on device. You can give any name of your XSVF file. Then this message will show program succeeded. If there is no error in your program, then this message will appear program succeeded, and your XSVF file is automatically created on your developed project folder. By the in the similar way, you can design any of the AND or NOR XOR gate. So it is a basic example how we simulate or implement our Verilog program on Verilog program on Xilinx, write program, simulate it, and then implement on it. But if we work research point of view, first of all, we need to knowledge of Verilog program. So now introduction to HDL, I'm going to discuss some small projects and then research work. Now, what is Verilog? Basically, Verilog is a hardware description language. Verilog is one of the two major hardware description language. VHDL is the another one. So, as I told you that Verilog is easier to learn and use than VHDL. Verilog is just like your C programming, C language. Verilog HDL allow hardware designer to design at a high level abstraction. Why we use Verilog HDL? Because digital systems are highly complex, and Verilog language provide the digital designer of software platform. We can simulate our before implementing. We can simulate our project or our code, and then make it a IC. So we can design even our own microcontroller on FPGA, and then after checking the syntax, behavior simulation, and implementing this on your FPGA, you can give your design to manufacturer company, and they will provide you your own logic IC. Now, what is the advantage of Verilog? Unlike all the procedural language like Java, Verilog is concurrent. Concurrent means here data flow in parallel form. Now, what is the design procedure? I already discussed. To create a Verilog file, first of all, we need to create a Verilog file, compile it, implement it, then create and simulate it. Now assign input and output. Assign input and output means we need to create a XSVF file, then download the bit stream or XSVF file on FPGA or CPLD. CPLD basically, excuse me.
F5 press करके ना screen खोलो.
F5.
आगे करके अपनी slide पे चलो.
Okay. Okay. Now implement your XSVF file on burn your XSVF file on FPGA or CPLD. CPLD is complex programmable logic device. Now we can test or implement it on FPGA. This is the design procedure which I discussed one by one. Now, what are the level of abstraction when we write program on Verilog? There are three levels of abstraction we can write our program. First, the low level is gate level, then data flow level, and behavior level. I will discuss gate level, describe the logic gates and the connection between logic gates. I will explain it via one by one example. Then data flow level, in data flow level, flow of data between register and behavior level, designing without knowing about the hardware. You can, I can explain it via example. First of all, gate level modeling. In gate level modeling, suppose I am taking a example. I am creating a module, give name gate level, and assign some variable. Write some variable a, b, y1, y2, y3, and y4. In out of these 6 variable, a and b are input, so we have to declare input a and b. Then y1, y2, y3, and y4 are the output, so we have to give output y1, y2, y3, and y4. Now in gate level modeling, we have to write these type of syntax: NAND N1. Sorry, this one is the y1. Sorry, NAND N1. This is the name, and y1 comma a comma b means we are performing NAND operation, and the output is v1 and your input is a and b. This is the writing how we write logic for NAND gate. Similarly for XOR gate, y2 is the output of XOR gate, XOR x1 is the name of XOR, and a and b. So a or the operation of XOR a or b, and the output is y2. Similarly for AND and OR gate. This is the gate level modeling. In data flow level modeling, here we use assign operator as we discussed in our first example. In this case, suppose we take an example, write module name gate, INV for inverter, and a comma b. So here I am declaring input a and b are the input, and out INV and AND are the outputs. So here we, in data flow modeling, we are using assign operator. Assign operator means INV is the output equal to negation of A. So negation of A will give to the inverter. Then assign AND equal to, we can give any expression, or we can simply write AND equal to A and B. And module. So this is the procedure how we write data in how we write our code in data flow modeling. So basically gate level modeling, data flow labeling, and behavior modeling are the 3 methods how we, by which we can write our Verilog program. So in behavior modeling, as you see in C programming, most of the cases, most of the program we use if and else statement, if and else, case structure. So in behavior modeling, we can do all these. In let's take an example, module example 1, x1, x2, x3. Here x1, x2, x3 is the input and f is the output. In behavior modeling, we have to take a same register of your name as your outputs. Such as if your output is F, you have to take register of same name F. Now always at the rate. Always at the rate means it work when there is any change in x1, x2 or x3. So when there is a change in x1 or x2 or x3, then it will begin. If x2 equal to 1, there is a logic. It is an example. If x2 equal to 1, if your input x1 equal to 1, then f equal to x1, your output equal to x1, else output f equal to x3, and is the AND statement of this begin, and AND module is the AND statement of this your this module. So I think it is very clear how we write code in gate level, then data flow level, and behavior modeling. Now, some Verilog statements. Which statements which are using in Verilog code? There are two basic type of statement. First one is concurrent statement, combinational, like this, which we used in gate level modeling, and z comma x comma y. Here z is your output, x and y is your input. Or c comma a comma b. Here c is your output, a comma b is your input. In continuous statement, you write assign operator. Assign, just write z, your output equal to x and y. So it is better to write this gate statement. You can use continuous statement and give name assign operator. Use assign operator and write your statement. You can write your statement. Second one is procedural statement, sequential statement. So in sequential statement, executed in the order written in the code. Here we use always at the rate. Always at the rate means executed continuously when the event is active. Whenever your event is active, always at the rate, this statement will begin as you show in this example. Always at the rate positive edge clock means when your clock is going to positive edge, it will become. And these statement which you write after begin, these statement will executed. Then end of this begin, if and else statement are also come into this sequential statements. As I already discussed, AND logic gate. If you I am taking as one more example, half adder. Half adder, in half adder we define module, half adder, sum, carry, A and B. A and B are your input, output, sum and carry are your output. So as we know that in half adder case, there is sum is basically a XOR B, and out carry is the A and B. So we can assign sum equal to A XOR B and assign carry equal to A and B and module. Similarly, we can design full adder. So in full adder, we this is a truth table of full adder, and we know that when all the three inputs are 1, your sum and carry will be 1. Otherwise, if 2 input are 1, then your sum will 0 and carry will 1. So this is a logic diagram of full adder. I will show all the what I am discussing till now. I will show you in a video. Let's see a video. Here, first of all, click on file, then create new project, give name. Suppose I give name full underscore adder. Here you can select the location where you want to save your data, save your project. Here I'm creating a new project and give name FPGA underscore STC. Now, for creating a new project, Verilog module, you have to select Verilog module, give name. Now here we write Verilog program module full adder A, B, C, sum, carry. This is the same procedure. Because we have shortage of time, so I come to the implementation step. Here you can see the simulation. For implementation, first of all, open the terminal and give the IP address of the system. First of all, click on terminal and give IP address of this system. Then click on ULK count, click on list ULK. It will show your IP address, then select it and click on connect. Now this connection established. Now here you load your access.vf file. In this case, here you can see they are actually the Spartan kit which I'm using have 3 processor, ARM processor, FPGA processor, and DSP processor. So for every project we need to select if we FPGA, if we want to work on FPGA. If we want to work on DSP, then we need to select DSP. So in that case, I'm always selecting FPGA. Now search this FPGA STC folder and search this one, full adder access.vf file. Click on it, then click on open. Now load it. Okay, click on OK. It will take some time, few seconds. Now file successfully loaded. Now click on run. Again select FPGA and execute. Then click on OK. For doing so, it implement your access.vf file on FPGA. Now FPGA programming success. Click on OK. Now this is the FPGA Spartan 6 kit. Here you can see these are the dip switches 1 and 2, and 1, 2, and 3 in case of full adder, and 3 LEDs. If I'm pressing 1, means 1 in 0, 0, 1, 0, then sum will be 1. Only some LED will glow. But when we press 1, 1, 0, then what will happen? Sum is 0 and carry will 1. And if we press 111, means both sum and carry will 1. Similarly, you can do for programming for 2x1 multiplexer, 2x4 multiplexer, decoder. Now I'm taking a case of 4x1 multiplexer. As you know, 4x1 multiplexer depends upon 2 select line. If both S1 and S0 are 0, 0, then D0 will appear on output. If 0, 1 select line are 0, 1, then D1 will goes to output. Then if they are 1, 0, then D2, and after that D3. So at a time 4x1 means any input, a single input can deliver to output, but one at a time. It depends upon the select line. So this is a Verilog module program, V program. Here you can see module mux D in, D select, D out. Output is D out is the output. So it is a program example of sequential programming. So when we take D output, D out, so similar name we give to the register D out. Because the inputs are 4 inputs, so here I am taking input an array 0, 3 means 0, 1, 2, 3. 4 bits for input, and these name are D in, and similarly 2 select lines, so we give name input 0, 1 because we using 2 select lines, select. Now always at the rate D in or select. If there is change in D in or select, it will begin if select equal to 0, means if the select lines are 0, 0, select lines means S1 and S0 are 0, then your D out equal to D in 0, because your D in is the input and it has 4 bits. So if select equal to 0, then D out equal to D in 0. Similarly, else if select equal to 1, then D out equal to D1, and so on. You can you can see the behavior simulation. If I am taking the input 1, 1, 0, 0 and select line is 0, 0. Now If your input is 1100 and when you select input, select line 00, now what will happen? This 0 bit appear on your output. When you select 01, then again 0 will appear on output. When you select 1110, then 1 will appear on your output. These are the 4 cases. Now I will show the video of this project. Now I am going to take only implementation part. Here you can see UCF file. I am taking 4 input switches, 2 select lines. Select lines are also for, we are taking 6 input, basically 6 dip switches, 4 for input and 2 for select lines. Then give D and net D out LOC. This is your single output, which is an LED. Same procedure will repeat. And implementation, same procedure. Here you select mux.xsvf file and load it. Now you can see. Here I am giving the 4 data input 1101. One 101 means if your select line is 0, then output will be 1. Similarly, you can verify your logic on FPGA. Now next one. You can do your programming in case statement. There is an example of BCD to 7 segment. In case of BCD to 7 segment, there are 2 type of segment connected to common cathode and common anode. In my case, when you want to blow this segment, so give 0 to it. If you want to off this segment, give 1 to it. So this is a table to BCD to 7 segment. Here's a Verilog program BCD to 7 segment. Here you can see I am taking BCD as an input, segment 7 and segment 7 select, because in my kit there are 4 segments. So to select any one of them, I need one variable, segment 7 select, and segment 7 which we want to display on your 7 segment. So these are the outputs. So we need to take output as well as registers. Now input is a 4-bit, so we take input 3:0 BCD, always at the rate BCD. Whenever there is a change in BCD, begin. Now select segment 7 underscore select equal to 4 in case of binary. When we write our data in binary form, so we have to write these 4 comma colon B 1110, because we have 4 segments and we want to select segment LSB segment, so we need to give 0 for it. So we write 1110. This is a case BCD. When you pass 0, then this is the code for displaying 0 on your 7 segment. We need to pass F9 on your 7 segment. Similarly 0 to 9. Then if you want to display A to F, then you can write these code. Then AND case, because we are working on case structure, then you have to AND via AND case. Then AND is the last statement of your begin. Then AND module. AND modules means this is the last statement of your project. Now you can see the video of this experiment. Here I am going to interface 7 segment via FPGA. Excuse me, ma'am.
Yes.
What's going on?
मैम आप खोल दीजिए, आपके नीचे का वीडियो
किधर?
प्रेजेंटेशन है ना जो पावर पॉइंट. यस.
नहीं, वो चल रहा है ना वीडियो.
वीडियो आपकी गायब हो गई है, वो फोल्डर, ये जो फोल्डर है ना, इसे देखिए।
नहीं, वीडियो तो ये रही।
हाँ, बस
ओपन कर दो। ओके ओके। Here you can see I'm going to the implementation process because it's a lengthy process, so I am going only on show only the implementation process, how actually it works. When you nothing press 0 0 0, then it will show 1. When you press 1, it will show 1, then 2. When you give 3 via switches, then it will show 3. And because I am there are 4 segments, I am selecting this segment, left hand side segment, so that's why I am giving segment select. So when what value you are passing from this switch in BCD form, it will show in your output 7 segment. 6, then 7, 8, 9, A, capital A, B. We write B in small form because if we write B in capital, then there is no similarity between 8 and B. C, small d, again E and F, so on. So we can interface now, up to now we interface at dip switches, LEDs and 7 segment via FPGA. Now, one more important thing, why in case of FPGA, for generating PWM signal via FPGA is very important. As you know, the PWM generation, here you can see, here I am taking a counter value because our FPGA is working on crystal frequency equal to 100 megahertz. So if we want to calculate the time period, it is 1 upon F. So we can calculate, means 1 single tick equal to 10 nanosecond. So if we want to give the counter value to 2500, then equal to 2500 into 10 nanosecond means 2500 equal to 2500 equal to your 25 microsecond. Now to convert in frequency, you can see that frequency equal to 40 kilohertz, means if we want to work on 40 kilohertz, we need to give counter value 2500. So means your counter is reaches 0 to 2500. So, and this is the reference value. Reference value is the value which is always it compare it with reference value. When it reach to the reference value, until it reach to the reference value, your T on equal to 1, otherwise your T on will be 1. So maximum counter value to equal your counter value equal to maximum switch. Then for 2500, for equaling this equation, you need to multiply a scaling factor. I am going to show in my program. Here I am taking, now I am going to generate a PWM signal via FPGA. So I am taking this example module PWM clock PWM switch. Here parameter SD. SD is the parameter here for scaling factor. To equalize these equation, I am taking SD parameter, input clock switch. Here I am taking 8 switches, means what I am going to do, I am controlling the width of, I am going to change the width of PWM via switches. Now this is your output PWM register. I am taking a 16-bit counter and initialize it with 0 value. Because output is PWM, so we take a register of same name, register PWM. Now always at the rate positive clock. When your positive clock is begin, then your counter is incremented by 1. Now if your counter is less than equal to SD, SD is the parameter which you already define in your program, 10 multiplied by SW. SW is the value which we are going to give by FPGA switches. Now whenever this parameter, your counter is less than equal to this parameter, then your PWM equal to 1. And when this condition is false, else PWM equal to 0. And what up to, if your counter is greater than or equal to 250, matlab means these equation will execute until your counter value is greater than equal less than equal to 2500. And if it is above, then your counter will 0 and AND module. This is the experimental setup to generate PWM signal on FPGA. This is the different duty cycle. I will show you with the help of some with the help of video. Again, for creating project, I am going to the implementation part. Here you can see I am giving some value to 8 switches, and here I am connecting the DSO and take the signal from FPGA. Here you can see via giving some value via switches, this waveform will appear. Now if we want, if I am change some value via switch, the width will vary. Yes, it vary. The width of PWM is vary. So we can change the value of switches. I am taking 8 switches, so you can change the value in binary. 8 times 1 means 0 to 255. We can change the value, and this you can see the width of PWM T on will increase. So what is the use? Why we using PWM signal? What is the use need of this generating PWM? Basically, in research point of view, in power electronics, if we want to control the T on T off time of a MOSFET or any power electronics device, so we use the concept of PWM. In next case, I am going to control the speed control of DC motor. Here you can see instead of switches, I am taking a potentiometer as an analog, and because potentiometer give analog value, then I am using an Arduino working as an external ADC, convert the potential analog value coming from potentiometer into digital, then giving it to this input output expansion port of FPGA. Now they give the output signal, which is PWM, to the ULN2003 IC. This is a IC used to control the speed of motor. Here you can see by rotating the value of potentiometer, the speed of the DC motor will vary. Now you can see this one. So we can use the concept of PWM in many applications. Next. This is the same program which I written in PWM program. And fire alarm and protection system based on RF. We can interface RF module with the help via FPGA. I'm just showing the video. Here you can see in this project, I am using 2 kits. One for transmitter side and another for receiving side. In transmitter side, I am using IR sensor and flame sensor. If there is any obstacle occur in IR sensor, then on receiving side, LED will be shown. And if there is an flame sensor, if there is they occur any flame in transmitter side, then buzzer will blow on receiving side. You can see on this video. Here you can see when any obstacle occurs and it detected by IR receiver, IR sensor, then LED will show on receiving side. LED will glow. Then if there is flame sensor detect any flame on transmitter side, you can see we can on any pump motor on transmitter side, as well as buzzer will beep on receiving side. So we can communicate wirelessly, communicate to FPGA kits. Next project is to control robot. Just a minute. Project. Okay. There are so many applications. Now in brief 2 or 3 minutes I will go to how we work implement any fuzzy logic based MPPT basically on FPGA. This is my project video. I will show. Just 2 minutes. Here I am taking a solar panel. I am taking 2 solar panel, fixed solar panel, and panel placed on sun tracker. Here you can see. This is my project setup. Basically, what is my project? To design an implementation of fuzzy logic based MPPT on FPGA. So when I am taking data, current and voltage directly from solar panel and without involving the MPPT, which I implemented on FPGA, then it will give this. This is the circuit of where I'm taking voltage and current and converted into digital form and boost converter. Here you can see that voltage is 17.23 without using MPPT. But when we apply our algorithm here, then this circuit is also on and this boost converter is on, and you can see then power and the voltage is boost up to 27.90. So we can implement any logic, any algorithm on FPGA and give better results. Thank you so much.
So we have come to the end of the session. Actually, I'm very sorry because she had a lot of material to discuss. I just told her to complete it because here also we have some other meeting here. So we have to leave at 1 o'clock for the meeting. So that's why I told her just so anyway, we are sorry for it. We'll give you a lot of another lecture where you can continue.
Actually, it is very short.
Yeah, the period was very short because I can understand because the last session also it went a little long. So period which we gave for her was little short. So we are also sorry for it. And I'll do one thing. I'll get the material from her and mail it to you. Both the experts who came today, I'll get all the material and mail so you can just go through it. So once again, Swati, we are very thankful for you for coming all the way and delivering this lecture. So now we will go on to the valediction. And
if you have any query, then you can mail us. And my mail ID is Hello. Yes, sir.
Ma'am, my name is Shailendra Kumar. I am from Integral University.
Okay.
Thank you so much for giving me a very valuable experimental explanation
Okay,
of
thank you.
Verilog SDL.
Yes, sir.
It's quite informative for us. Basically, I am performing a lab for MTech students.
Okay, okay.
Right now, I would like to, one question.
Yes, sir.
Is there necessary for test bench? Test bench is required?
No, sir. No test bench is required.
Actually, suppose I have written a program on Verilog, and
Yes.
I would like to implement on Xilinx.
Yes. There is no
Is there
need to simulate it. You
test
can
bench
directly
required?
implement it. Sir? Hello?
Can you tell me test bench is required?
No, sir. There is no need of any test bench if you want to implement directly. So you can, no, you don't need to go for simulation. You directly implement it.
Okay, ma'am. So, in which case test bench is required?
Test bench is basically for simulation purpose. So if you want to simulate your project before implementation, then you need test benches, otherwise not.
In this program, I think that we are simulating this basically.
Yes.
If I'm correct.
I
I
am
haven't seen any
we
test bench
simulate
program.
as well as simulate as well as implement all the projects.
Okay, in this program, when you are explaining how to perform it, so you are using to implementing basically this project, है ना? So I
We
would
are
like to know that
implementing
I
as well
haven't seen
as
any test bench. Actually, would like to understand about it. I haven't seen any test bench.
okay.
So one thing that I would like to know, one more question, that is test bench required?
It's up to you. If you want, then it's required. Otherwise, you can directly implement.
Okay. Thank you. Thank you,
Okay.
ma'am.
Thank you,
Thanks a
sir.
So good afternoon, everyone. We are just having the valedictory session of this short-term course on tools for engineering research. And she needs just one minute to take over. I have to take the certificate of the participant. Respected Dr. Poonam Sayal, Dr. Ritula Thakur, our two experts, Swati and Sandeep, and the dignitaries and participants at various nodal centers and the participant at NITR, all faculty, staff, a very good afternoon to one and all. So we have come to the end of this session or end of this course on tools for engineering research. It was a 1 week duration course. We had number of experts. I would like to thank all the experts for coming so long and delivering the lectures. So before going to the next session, I just want to get the feedback from the different nodal centers. So feedback, we'll have a small session of the feedback. So first, which center shall we go?
Ma'am,
RTU.
ma'am, Integral University.
Integral University. Integral University can just give your feedback.
Hello, ma'am. It's Preetam.
Yes.
Sir, ma'am, your session was very good, and especially the Arduino connection with MATLAB, that was very new for us, and the Xilinx programming. Actually, we are developing some robotics, and we have some project also for government. So it will be very helpful for us, and we will develop surely some hardware. Thank you.
Okay, thank you, sir. And what about it? Would you like to give any suggestions about the course?
Ma'am, there was some tools which are paid, like Xilinx is also paid, and Turnitin was paid, and you have used a link for downloading paper.
Yeah.
So that those links are actually paid. So can you suggest some free tools which can used normally by students?
So actually, there are open source for checking plagiarism also. Number of open source are there, but as I already told you on that day, there is some problems also. Once you put your material into it,
sometimes somebody else could use your material. Okay, so if you really feel it is your own paper, you have written it, then if you put the material into that open source software, because there you're checking the plagiarism, so somebody can use your thing. And the other thing is when we check it in open source, the percentage will be very less. But when you send it to SCI journal, they would have given our students also face the same thing. It was only 20% they send it. Now, from the conference, it has come as 70%. So you have to, when you want to check plagiarism, it is better you go for this Turnitin or Authenticate like standard software. And I already told you, you can tell your university to get it. It is around 3.3 lakhs. Sorry, 3.5 lakh per year, 100 student license and 3 instructor license. So it is better you can go. Otherwise, you have a lot of software. Open source, you just search in Google, you'll get a lot. But it is preferred not to go for such software. And another thing is FPGA. FPGA also for such applications there is no equivalent. Okay, microcontroller, okay, it's cheap and you have number of, but for FPGA, I don't think so. For Xilinx or this Fortress, such software, only you have to go. So if you're really purchasing that FPGA hardware, with that itself, the software also will come. Because only with software, you're not going to do anything. You require the hardware also, no? So it is
Yeah, exactly, ma'am. Exactly, ma'am. In the place of MATLAB, can we use Scilab? Actually, Scilab is a free version of it, so that everyone can utilize that.
Yeah. And so here I would suggest, like just like Scilab, there is one GAMES software also, GAMES. That is also for coding purpose, just like MATLAB, and in that the coding is much simpler.
Okay, thank you. That's my suggestion, that in the place of paid software, if we can use open source software for teaching, then it will be fine for students and teachers also.
Very good. Like when you go for software, let's say MATLAB, in the place of MATLAB, you can go for Scilab, even R. R is also a very good software, open source. That is for simulation purpose. But I don't know how much plugins they have or tools they have for connecting hardware. Okay, whenever you want, say, why do you simulate all these things? You want to put it into a real time. So might be they are also developing even in our Scilab and all. But it might be in the initial stage. I'm not very much aware of the hardware implementation. So if you really want to implement it, you can go for MATLAB or LabVIEW. Okay, hardware implementation. But otherwise, we also conduct courses on Scilab and R. This time also we had, but it was cancelled due to some reason. Next OPLAN also we have the Scilab and R for electrical engineers or common engineers. You can just go through our OPLAN for such courses. It will be dedicated for such application.
Okay, and can we do something for technical writing in the next program? If it happens.
Yes. For technical writing also, like we have here Poonam ma'am, she conducts courses, and that I think technical writing also.
We can add.
We can add this. Yeah, surely we'll add this on technical writing also. We'll add. And I already told you about for paper downloading also. You were asking. I have told about the SCI Hub.
Yes.
Okay, www.sci-hub.com. So there, sorry, .cc. There you will get technical papers. You can download.
Thank you, ma'am.
Okay, thank you, sir. So now we will move on to the next center, Adani Institute.
Very good afternoon to you all, madam.
Good afternoon, sir.
Yeah, I am highly thankful to NITTR for conducting such an informative presentation. In fact, all the session was very informative and very helpful to all the young researchers. Okay, and it was very attractive, particularly the session related to the MATLAB and its hardware implementation with Arduino and FPGA. Okay. One thing I want to know that is there any way to cross check particularly the plagiarism from my own paper? Suppose I have written I have published 4 paper and I am writing another paper and I want to check the plagiarism from my own paper. Okay. So usually what's happened that mind of a particular person get biased and he uses the same phrases, same sentences in order to write the same thing. So I want to check the plagiarism from my own paper. So is there any software or any way that I can check the plagiarism from my own paper?
So as such, for the same paper, say in Turnitin also, once you check, all the link will come. There itself, you can see your own paper. Yesterday also, when I showed
Actually,
okay, our papers also will come, and from our paper, how much percentage it is coming, that also will be shown there.
actually, Madam, Turnitin is a paid software. So is there any alternative way to use to find a plagiarism?
Many open sources are also there, but I told you the disadvantages. You have to be very alert because when you are doing PhD, you don't want to give your material to anyone, is it? If it is, say, your simple papers, it is okay, you can go and check it. But once you're doing PhD and say you have put the material from some other country, the people may use it, they may publish before you, changing it. And after that, you will be caught. So it is better when you are doing some good research, don't try to, like, we have to pay for it. So it is not necessary, you can go for nearby universities where these softwares are available. Okay, so Turnitin, Authenticate, these are some of the standard things. I already told you, we have also faced this problem when you send your paper, when we see in the open source, sometimes it gives you that there is some plagiarism, but the correct percentage will not be correct. Because all these Turnitin or all those other good paid software, they have a good library resource. They have all the materials with there where they go and check it. But the open source, some of the libraries are not accessible for them. They won't give you the correct result. Okay. But in Turnitin, there is an option for seeing the plagiarism of your own paper also. That will be shown. And if you want, even you can delete those things, saying that it is my own work. There you have self-plagiarism, you can remove it.
Thanks, madam. And once again, I present my heartiest thanks to NITTR and hoping very soon to join such session for research activity. Thanks a lot.
Thank you, sir. So, I remember you seeing throughout the course. So, thank you for attending all the session. So, he was one of the person who was there throughout. Yes. So, thank you, sir. Thank you. We'll now move on to the next part. PVP Siddharth. So, here PVP Siddharth also, I've seen these participants.
Vijayawada, na?
Yeah,
they are very sincere.
Hello, ma'am.
Yeah, yes, ma'am.
Hello, ma'am.
Yeah, yes.
From ICT.
Yeah.
The entire journey for this short-term course is very interesting. But only thing I need to know that Arduino software you have given now, ma'am, regarding interfacing with MATLAB programming.
Yeah.
Ma'am, Arduino is not, can we extend that one for further applications? That means if you want to apply for any related to power systems area or what are the application, in that case, can I apply that Arduino software, ma'am?
Yeah, yes, ma'am. Really, it can be used even for PhD or MTech. You can see here, Sandeep, today he was delivering a lecture on Mega, I think. His research work was on 5-level multi-level inverter. Okay, so it multi-level that to 3-phase. So there also say this Arduino is just a controller. Your power system is the power circuit. In order to interface this and that, you have the power circuit and the control circuit. In between, as I already told you, you require optocouplers or you require driver ICs. So it gets isolated. So the power control circuit has nothing to do with the power circuit there.
Whereas programming path, when you want to interface, programming has to be taken care from that Arduino itself. No, there is no chance to change the program, no, ma'am.
No. So what you can do is, once your application is, say, even you can make a fax device out of this. You made a fax power electronic device, you're firing, you're getting it from the Arduino. So you can interface it with MATLAB. Okay, so now if it is a research application, you can create a EXE of MATLAB. Okay, and have that EXE in some, say, now mobiles also, it comes very cheap, 2,000, 3,000. So you put that EXE in that mobile and connect it with your Arduino and make it as a dedicated application. Okay, when you do PhD work, when you want to have it dedicated, you can go for some applications like that and make this whole system dedicated, standalone. Here we are showing it with computer, but this computer can be replaced by your small mobile phones or some other Digital
Digital.
divide.
Yes.
Even in lab it is possible. In lab we also you make the EXE, create the
Yes,
EXE. So when you create the EXE, what will happen is all the supporting files will come into it. So then MATLAB or LabVIEW is not required. It becomes a dedicated application.
Okay. Actually, I also thought to have question on plagiarism software, but earlier other remote centers are also have same question. So it will be better if other than turn it in. But anyway, the entire section is very good, ma'am. And we expect to have the same for future purpose also. Ma'am, can you provide PPTs to our remote center, ma'am?
Yeah, sure. Only some of the experts have given it. So those experts who have given, I'll just share it to you. Because I'm just waiting for these people also I'll get, because I don't want to send it separately. I'll get all the experts and I'll put it into one module and I'll send it to all the nodal centers and the participants here.
Okay, thank you, ma'am. Thank you very much.
Okay, thank you, ma'am. And we next move on to
GP Betul.
Government Polytechnic Betul. Government Polytechnic Betul, are you hearing us? Are you hearing?
We can see you.
Yeah, we can see you, but we couldn't hear you. Can you hear us?
बस सिस्टम के पास आके रिप्लाई कर दीजिए.
Yeah, somebody is there near the system, but I think they are not able to hear us. Are you able to hear us? Please wave to us at least. Can you hear? Yeah, they can hear us. So we want your feedback. Mic is off.
Then is your.
I think your mic, you just set your mic. By the time we'll go to the next center and we'll come back to you. Jodhpur. Jodhpur Institute. Jodhpur Institute. Engineering.
Hello.
Yes, sir.
सर ये आपके पास है कि कर लीजिए, ये माइक मत यूज कीजिए.
सर आप अपना एक्सटर्नल माइक मत यूज कीजिए, आप अपना जो लैपटॉप का माइक है
Because it's we get some disturbance.
एको आ रहा है उससे. सर आप अपना एक्सटर्नल माइक मत यूज कीजिए, आप अपना
Hello.
Hello, sir. Yes, we can hear you.
Am I audible?
Yes.
Good morning. This was really a very enlightening course, and because a lot of MATLAB was involved in this, today itself in both this hardware validation using microcontroller by Mr. Sandeep Gupta, and a lot of image processing was also into that. So that made it very interesting, and that would definitely help us in a number of good projects. We have already planned for some, and that gave us a new insight into that. So that was very good. Almost 4 programs were on MATLAB, and overall it has been really helpful for all of us.
Okay. Thank you, sir. Next sentence. North Cap University. Hello, ma'am. Yeah.
Ma'am, we cannot hear you.
Hello, ma'am. Yeah. Hello, ma'am. We can't hear you.
Can you hear me now? Hello?
Yes, ma'am. We can hear you.
Yes. Ma'am, the sessions were very good. And I really liked the session on optimization yesterday evening. It was such a nice session in which we could understand optimization in so simple language. Sir presented it so well. And the plagiarism session was also very nice, where you talked about Turnitin. We are also using Turnitin for the same. But my query was, like, if I want to send my paper that I presented in a conference and I want to send its updated version to a journal, what should I keep in mind? Like, what changes, like I have made some changes related to the implementation and all that, but the theory part is the same, but it is showing plagiarism more than 20%, of course, because the theory part was same, but it was related to my work only. So what should I do? Is it being considered there as a bad thing?
Yeah, actually, ma'am, sending, say, once we have published a work, it is fully published, the publisher. Okay, so you have to get a permission from them saying that that work I want to get. But usually we don't do all these things. We don't do about that. But you have to send them a mail. Even say if you send it to elsewhere, or say if it is IEEE conference, then we have to get permission from that. Ki my own work, I'm extending it and I'm sending it to the other journal, and you can do it. Or what you have to do is you have to fully change the wording.
Okay.
Otherwise, it will show you plagiarism. Say the journal people, when they check even self-plagiarism, they will not consider it. They will say you have plagiarism and they will reject your paper. So that, so in that case, what you can do, you can fully change the wordings.
Okay.
Paraphrasing, that is plagiarism which I told you.
I should rephrase that you told earlier also, but it was like the same paper in extended form I was sending. So I was just asking that.
So that is said to be paraphrasing plagiarism. That is also not allowed. But the thing is, if you cite it, whenever you do it, you cite that from that paper that is taken from your paper, then it is not a problem.
Okay, so I can make self-citations, and that is not a bad thing, I guess.
Self-citation, but the better thing is you send the concern to the particular conference, because they have the copyright of your paper. You have to tell them, I'm using this material. So you will get the concern, then you can publish. Because they also...
Another thing is, it depends upon the conference, because recently I sent my paper to an IEEE conference and they have very strictly told that self-citation is not allowed.
Yeah, that's why, like, I just
journal or the conference their own rules also. Not necessarily.
Because self-citation is generally treated as bad.
Yeah, it is not allowed.
So, okay. Thank you very much. It was a very wonderful session indeed. That Arduino part also, I liked. My student is working on that red thing, red, yellow, and green light stuff to make measurements related to the dress a person is wearing and some hand gestures also. So it was wonderful session. Thank you very much.
Thank you, ma'am. So we have the next center. This is Betul. So you can just give your suggestions.
Very good afternoon to all. And we are very thankful to Energetic Chandigarh for organizing such an informative session. And we all learned a lot from all the sessions, especially of Dr. Amod Kumar sir. We took the sessions in very interactive and light manner. So all participants and all professors from our college enjoyed a lot during his lecture. I may emphasize on the word enjoy, because the sessions in very light manner. Other than that, all sessions were very nice. Some sessions in depth, and since our program is interdisciplinary, so some sessions were on the high note. But other than that, all things were very nice, and the sessions were very informative. So we are very thankful to Energetic Chandigarh. Thank you so much.
Okay, thank you, sir. Thank you. All the centers are over?
Yes, ma'am.
So I think now almost all the centers are over, and I thank all the coordinators, and like I have a formal auto thanks. Before that, I just like to give you some information that all of you, please, I think 3 government institutes are there. Please send me all the bills. First of all, you have to send me the list of participants in the attached form. I have sent you a mail where I have attached the Excel format. So please send me your participants list in that format. That is the first thing. You should have your registration first day when you have done registration. you would have got signature, or even if it is not the attendance sheet, you should have all the attendance sheet. And for the non-private, like non-governmental institutions, you can send your ancillary staff and the coordinator bill also. And along with this, have a letter where you have to just mention that the IFSC code and the bank details to which we have to send your amount. Okay, and PAN number and the PAN number of the coordinator and the co-coordinator. Their bank details can also be given if you want to transfer to their bank, and with their PAN number also. Okay, so these details you have to send it to us, and see that you send it very fast, because we have number of courses going on, so we will get confused with all those things. Okay, so it is better if you send it next week itself. We will send it for processing, because it is the end of the year. Sometimes if these bills, it is the end of the financial year. So by March, all these financial things will be closed. So it is better you send it as soon as possible, so that we will process it before this March. If you go to next March, then it will be a problem for us. Okay, so please, all of you, send your details as soon as possible. So now we are going to the end of the session, and I feel privileged to express my vote of thanks to all who were involved in the conduct of this program. First and foremost, I would like to express my gratitude to all the coordinators of various nodal centers and the liaison officer at NITR Chandigarh who have arranged for the connectivity of this program. I am highly thankful to Dr. Tulsi, Director NITR, for her support. Thanks are also due to all the members of the ETV department, without whose involvement this program could not have been materialized. Let me sincerely thank the faculty in charge Internet Administration and his team for arranging the internet connectivity. From the core of my heart, I would like to thank Dr. Poonam Syal and Dr. Rutula for their support. In the end, let me also thank all the participants, without whose participation this program wouldn't have been materialized. And I would also like to thank all the experts who have spared their time with us. Lastly, let me not forget the names of the different departments and individuals who have extended their support in the conduct of this program. The Institute Estate Department, Electrical Maintenance, Media Center, Canteen and Mess. My overwhelming thanks are also due to these departments and every individual involved. Let me also extend my heartfelt thanks to all the faculty, staff members, PhD scholars and ME students of the Electrical Engineering Department who have taken real interest in the planning of this program. Now let me take a close. I thank one and all. Thank you very much.
So in the end, we would like to congratulate Dr. Shimi, who have conducted this program in a very efficient way, and she has arranged to provide you the best inputs with regards to almost all the aspects which are required in the field of tools for engineering research. So we hope that we'll meet you again in our courses through ICT also and through contact mode also. So thanks to you all once again, and we are thankful to our participant at our institute also.
So I forgot, like in the running thing, I forgot we have to give certificate. Before that, let us hear a few words from Dr. Ritula Thakur.
Thank you, Shimi. As ma'am also said, I would like to congratulate Shimi, and because I know what all efforts she has done in conduct of this course, arranging experts and their lectures. It's not an easy thing. And as I've seen that all the participants there, they have also taken keen interest and listened to all the lectures. I'm thankful to all of you. Thank you so much.
So now we have a participant here. Let us first hear her feedback. So we just want to hear your feedback, and then we will give the certificate.
Actually, I am just coming for seeing how ICT workshop is conducted, and maybe something I learned. But when I came, I learned a lot of things. I am totally unfamiliar with MATLAB, LaTeX, and I got some engineering research tips. So I just very valuable session.
Okay. Thank you for coming. Okay, and if possible, you can also connect your college as a nodal center.
Which college?
You are from which college?
Eternal University.
Okay, Eternal University. So you can even connect your institute. Okay, so you can even connect your institute as a nodal center. And for the other nodal centers also, I think many of them have left. We have two more, I think, two more ICT or some other ITs are also there?
I think two
Only two only. We don't have it. So two more ICTs are there. One is fax devices and distribution generation, which is next week from 6 to 10. And one more ICT, it is in March, second week, I think. So if anyone is, any of the institutes are willing to connect us, you can do it. Okay. And now I just ask Poonam Sial ma'am to just hand over the certificate to Karamjit.
Thank you very much.
Okay.
Thank you. Thanks to all.